Hi algebra students, please grab your 5-9 trial by error and grouping factoring notes template. Try the warm-up for me, just like Mrs. Porter has you do. Please pause the video, try the 2 warm-up questions. They should be review from prior sections, and then unpause it to check your answer. So for the first warm-up question, you want to factor. You'll notice that each of the 3 groupings of x minus y match. And so what we can do is pull out the terms that I've highlighted into one set of groupings and then a second set of x minus y, because that is what they all have in common. There are some like terms in the first set of parentheses, so the final answer we would be looking for here is 2x minus y times x minus y. The second warm-up question is actually a 2x2. You want to look at the first 2 terms and the second 2 terms and pull out a GCF from both. The first 2 terms have a p squared in common, leaving me with p minus 3. The second 2 terms have a 2 in common, leaving me with p minus 3. I want these to match, and they do. So final factored form would be what is in front of the parentheses, p squared plus 2 times p minus 3. And when you look at this grouping, you know that that is factored all the way because it's not a difference of squares. So jumping into the first example today, we're going to talk about what if there is a coefficient on the quadratic term. And just a review of the words there, this term with an exponent of 2, this is called our quadratic term. The middle one, the x term, is called our linear term, which should sound familiar because we've used linear equations a lot this year and graphed them, and their graphs were lines. And then our last term is a constant term, and that should be familiar vocab from pre-algebra. So looking at this problem, the reason it looks a little different here is because you have a coefficient on the x squared term. So we are going to address this by looking at the 14 and the 5 of the constant term. We want factors of 14 and 5, so they both get addressed there, that add up to that middle term's coefficient 17. So we've kind of set up the work here. If you think about the factors of 14, we've got 1 and 14, 2 and 7, which is actually the pair we're going to look at. And for 5, it's a prime number, so just 1 and 5, and we're going to use 1 and 5. So a combo of those 2 sets of factors that would add up to 17 is what we're looking for. If we take 5 times 2 and we add it to 1 times 7, we will get the desired 17 there. The constant term, the 5, is positive, so both signs are going to be the same. They're going to match. And they match what is on the linear term, which is the second term. It's negative, so both signs are also going to be negative. But I don't really like the phrasing there because instead of them being negative, it can also be seen as subtraction. So I'm going to put both there. So when we're looking at the way this is factored, we want to think about the order within the parentheses. Obviously, we're going to have an x on both of the first sets of parentheses. We've already talked about how it's going to be a minus. And we're going to start with thinking about 2x times 7x is going to give me the 14x squared that I want. So the placement needs to go there. And we want the -1 and the -5 to go there. But some students don't really like this method because there's a lot of guess and check. You could have filled in these factors in the incorrect order, and hopefully you're checking them by foiling. But unfortunately, if you don't foil it, or if you do foil it and you have the wrong order, you're going to need to start again, which is where the trial and error comes into play. But there's a little bit less guess and check with this method that we call factor by grouping. Okay, and that's how we're going to look at this same problem again. So let's just pretend we haven't seen this problem again. And the first step for factoring by grouping is to multiply the quadratic coefficient and the constant together. So that 14 and that 5, if we take their product, so 14 times 5, which is 70, we're thinking about factors of 70. So we actually want factors of 70 that add up to negative 17, which is the coefficient on that linear term, that middle term. And when we think about that, for 70, 1 and 70, 2 and 35, but eventually you're going to think of negative 7 and negative 10, which give me the negative 17 that I want. And you can find this pretty easily by listing the factors over here. We would think about these pairs, and then we would eventually get to the one we want, which is negative 7 and negative 10. So what we're going to do is we're going to rewrite the problem, but we're going to replace the middle term. So this is the original problem, 14x squared minus 17x plus 5. We're going to replace that negative 17x with the two factors that we talked about that add up to that. So we talked about a negative 7x and a negative 10x. So I'm kind of just replacing that middle linear term with two terms that add up to give that to me. Well, this isn't in factored form, so what I'm going to do is I'm going to switch parentheses around the first two terms, 14x squared and negative 7x, and the second two terms, negative 10x and 5. And then what I'm going to do is I'm going to factor out a GCF from both of those. I'm going to do that work over to the side. So 14x squared and negative 7x have the same thing in common. They have a 7x that we can pull out a GCF. That leaves me with 2x minus 1 in parentheses, plus the negative 10x and the 5 have a negative 5 in common. Remember, when you've got a negative there, you usually want to pull out a negative. 2x minus 1. And the reason I know I'm in business is because these two sets of parentheses match. So my final factored form would be the 7x minus 5, you could also have plus negative 5, times 2x minus 1. And then, of course, you want to FOIL that to check it. So here's one for you guys to try on your own. We want 2x squared plus 7x minus 9. Sorry for all the rustling. So you're going to take the first coefficient of the quadratic term and you're going to multiply it by the constant term. So we want factors of 2 times 9, which is 18, that subtract, and the reason it's subtract is because the last term is a negative, subtract to 7, that coefficient on the linear term, the middle term. So thinking about the factors of 18, we've got 1 and 18, 2 and 9, and I can actually stop there because 2 and 9 have a difference of 7, which is what I want. So I'm going to write the original problem, 2x squared plus 7x minus 9, but I'm going to replace this middle term, this linear term, with the two factors that I found that add up to it. Now, you want to be careful with the placement here. I'm going to put the 2x next to the 2x squared because they're kind of similar, 9x and minus 9 next to each other. And notice how I'm kind of placing them intentionally so that I can pull out a GCF. If for some reason you had these two switched, the parentheses, the GCF and the parentheses that you pull out would not match. And so you would need to rewrite it with a different order. So pull out the GCF and see if you can factor this one to the finish line. Okay, I actually had a mistake in my work. This should have been a negative, so make sure that you have got that as a negative 2x. That would make it an x minus 1 that matches. So final factored form would be this 2x plus 9 times x minus 1. Now I want you guys to try to factor the next one, but you'll notice my hint here. You need to pull out a GCF first. So before you even jump to this new method of multiplying the coefficients, 15 and 18 is going to give you a rather large number, so you want to pull out that GCF first. So I pulled out the GCF. The GCF that they have in common is a 3, leaving you with a 5x to the fourth plus x squared minus 6 in parentheses. So that means that you're looking at factors of 5 times 6, which is 30. You want them to subtract because the constant term at the end is negative. Subtract to 1, the coefficient on the middle term, the linear term. So the two factors that you would think of here are going to be 5 and 6. So I still have this 3 out in front, but I'm going to replace the x squared with the two terms that are going to subtract to 1. So I want a negative 5x squared and a 6x squared. And then I'm going to factor the two pairs and plot a GCF. So from the first pair, I've got a 5 in common and an x squared. That leaves me with x squared minus 1. And then over here, from the 6x squared minus 6, I've got a 6 in common. X squared minus 1. Now I'm in business because these match. So I've still got that 3 that I pulled out in the first step of factoring in front, times a 5x squared plus 6, times an x squared minus 1. But unfortunately, I'm not done because this is a difference of squares. So I can break that down even further, leaving the first two terms in my factored form alone. I can't break them down any further. But x squared plus 1 can break down into x minus 1 and x plus 1, leaving me with this whole thing for my factored form. Now, if you look at number 2, example 2, the reason this looks a little weird is because the quadratic term is at the end, so let's rearrange it. And when we rearrange it, we're going to get negative 6x squared plus 11x plus 10. Now, I don't like that this is negative, so I'm going to go ahead and factor out a negative 1. That's going to really seem like I'm taking the opposite of all these terms. So it's going to be a negative 11x and a negative 10. I apologize for the animals in the background. So then I want to find factors of 6 times 10 gives me 60 that subtract to, not 10, middle term is 11. The two factors that are going to do that for me are a 15 and a 4. And the 15 needs to be negative because the 11 is negative. So I've got a negative 1 out in front. 6x squared minus 15x plus 4x minus 10. I'm going to pull out a GCF from each of these pairs. So that gives me, let's keep it in brackets, that gives me a 3x I can pull out times 2x minus 5 and a 2 times 2x minus 5. These match, so I'm happy. So I've got a negative 1 times a 3x plus 2 times a 2x minus 5. And just a quick check, those cannot be broken down anymore. So that is my final factored form. For the last one, I want you to try the entire thing on your own. Pause the video, try to fill in the I want statement, factor it completely, and then unpause the video to check. Okay, so final factored form should be 5a minus 11b times a plus 2b. You could also have this as plus a negative 11b as well. At the very bottom of your notes, it asks you to start writing down some factoring rules that you need to remember. Remember, the first step of factoring from anything is to check to see if you have a GCF that you can pull out. But then I want you to see if you can work out some steps of factoring by looking back at your section 5 factoring notes and seeing what we did, because we started with the GCF and we worked our way up in difficulty. So it's really important for you to list those steps so you know what you're looking for every single time. Bring any questions you have to your math teacher on the next instructional day.